Exhibit A, the phrase "science says." Not "one model suggests," not "this is a live hypothesis," but "science says." And once that phrase gets attached to the multiverse, string theory, or some cinematic explanation of reality, the trial is basically over before evidence is heard. So today I want to put one claim on the stand. Are science communicators explaining frontier physics, or are they quietly upgrading speculation into fact because certainty performs better than uncertainty? Now the defense gets a fair hearing. Speculative physics is not nonsense by definition. String theory, inflationary models, many worlds interpretations, extra dimensions. These are serious intellectual attempts to solve real problems. Some are mathematically rich. Some are internally coherent. Some may even turn out to be right. That is not the charge. The charge is presentation. What the video world often sells is not disciplined uncertainty, but the emotional experience of certainty. And this is where language starts doing sleight of hand. In public science discourse, the word theory gets stretched until it covers two very different things: a theory with deep empirical support, and a speculative framework still waiting for decisive tests. Those are not the same category, but the edit often treats them as neighbors. Say Einstein's theory and string theory in the same breath, and you create the impression that they differ only in difficulty level, not in evidentiary status. So let's cross-examine the format itself. What does a YouTube explainer reward? Clean arcs, big reveals, a sense that the universe is one elegant paragraph away from making perfect sense. What if reality has 11 dimensions? Is a fantastic hook. Here are the unresolved measurement and falsifiability problems is not. The incentive structure appears to favor awe over epistemology because awe is clickable and caveats are friction. To be fair, good communicators do something much harder. They let the uncertainty stay visible. They tell you what the model explains, what it fails to explain, and what would count as evidence against it. They resist the temptation to turn a beautiful mathematical possibility into a narrated inevitability. That is real science literacy, not just learning the answer, but learning what kind of answer you're being given. The weaker version, the one I think deserves criticism, uses scientific aesthetics as a credibility shortcut. Equations on screen, cosmic B-roll, a calm authoritative voice, a title that begins with "physicists discovered." Then somewhere in the middle, a speculative idea is introduced with just enough hedging to be defensible, but the surrounding tone tells a different story. The format rewards the feeling that we're watching settled knowledge, even when the content is closer to an informed possibility map. Take the multiverse. There are multiple ideas that get called the multiverse, and they do not all stand or fall together. Some emerge from inflationary cosmology, some from quantum interpretations, some from string landscapes. Already, the conversation is messier than the thumbnail. But the public version often compresses that mess into a single emotional message. Scientists think there are infinite universes. Maybe, in some frameworks, under contested assumptions, with unresolved testability questions. Those qualifiers are not footnotes. They are the story. String theory gets framed the same way. It's often introduced as the almost there master key of reality, one framework to unify everything if only experiments would catch up. That framing may be emotionally satisfying, but it also nudges viewers toward a verdict the evidence has not delivered. What is proven? It generated profound mathematics and influenced theoretical physics. What is implied? That nature must work this way because the equations are gorgeous. What remains unproven? Whether the universe actually uses that machinery. And before anyone shrugs and says this is harmless, here's why it matters. Once viewers are trained to confuse explanatory confidence with evidentiary strength, they lose the ability to tell the difference between established science, frontier research, and pure conjecture. That doesn't just distort physics. It distorts trust. It makes science look like a brand voice instead of a method for surviving contact with reality. And when the public later discovers that a glamorous claim was tentative all along, the backlash doesn't hit the thumbnail. It hits science itself. So the verdict is not that science communicators should stop being exciting or stop talking about speculative physics or turn every video into a disclaimer seminar. The verdict is narrower and more serious. Label the uncertainty honestly. Separate tested theory from elegant conjecture. Don't smuggle prestige from one into the other. Wonder is not the enemy. Confusing wonder with Warren is. And if a claim becomes less thrilling once the caveats are restored, that's not a failure of communication. That's the truth finally getting equal screen time. If you want more reviews that put big, confident internet explanations under oath, not to kill the fun, but to separate what a video proves from what it only suggests, subscribe to Dr. Review. Next time, we may be looking at another piece of obvious science content and asking a much nastier question. Did the video teach you something true or just something satisfying?